Okay, so the goal today is I'm going to review some calculations that we might use in environmental science. And if we have enough time, I'm going to review the biologies that we need, the biology background that we need in environmental science as well. Okay? Okay, so first of all, okay, first of all, because we know that the environmental contaminations are often present at very small concentration, right? So what we are going to learn is we are going to convert a large scale into the small scale, but the value will be the same. Okay? So, for example, like this one. So we have 17.5 milligram. .5 milligrams lead. So this is lead. In 1 kilogram of soil. I want to convert this into ppm. And ppm stands for parts per million. Okay? ppm stands for parts per million. Okay, and ppb, the B here stands for billion. Okay, and as I show here, 1 ppm equals 1 milligram per kilogram, right? So we want to convert this, so this is, so 1 ppm equals milligram per kilogram, so this equals ppm. This one equals ppm. Okay? Okay, have a seat. Okay, so let's convert this to, so first off, let's convert this into grams per grams. Let's convert this into gram per grams. So M stands for 10 to minus 3. Everyone know about this, right? And K equal 10 to the power of 3. Okay, so this 17.5 milligram becomes this. Okay? And 1 kilograms. Okay, K stands for 10 to the power of 3. Okay, so in this case, we got this 7.5 gram per 10 to the power of 6 gram. So as I just told you, ppm stands for parts per million, right? So this equals 1 over 10 to the power of 6. So this amount equals ppm. Understand? In this case, we also know, so after these calculations, so after this conversion, we also know 1 milligram per kilograms equals 1 ppm. Okay, the same here, the PPE, the PPB parts per billion equals 10 to the power of 9, so equals 10 to the power minus 9. So 1 over 10 to the power of 9, so equals 10 to minus 9. So this equals 10 to minus 6. Okay? And ppm is very useful if we try to measure the concentration in soil, concentration of contaminants in soil. Okay, so this is in the mass concentration unit. The M here, okay, the subscript M here, this means mass based. So gram per gram. Okay, and if we turn this into, so this is the solid contaminant over solid, right? Like soil. So in water, if this is in water, it will gonna be 1 milligrams per liter. So 1 milligram per liter, this also equals 1 ppm, write this down. Especially this is in solutions. Okay, and if you use kilograms, it's in solid. Okay, let's move on to the next slides. Okay, in so this is solid materials. The solid samples. How about the liquid sample? So for example, like we have 0.35 milligram per liter, but I already told you the answer, right? But if you don't know, let's do the conversions. Okay, so we need to make into gram per gram, right? We need to make it into gram per grams. Okay, and this is the density. Okay, this is the density of water at 5 degrees Celsius. Okay, so we convert. So we convert the volume into mass, right? So you know, so the density equals mass over volume, right? So mass equals density times volume. So we times its density. So we got the grams. So it's 0.35 gram per grams, right? 10 to the power 6. So as I just told you, this equals ppm. Okay? So we also know this. After conversion, we also know this. the milligram per liters. The milligram per liters, this also equals ppm for liquid sample. Okay, so let me conclude here. So ppm equals mass of solute over mass of solutions. And I just told you the M stands for million years. So you need to time 10 to the power of 6. Okay? And the density of water at 5 degrees Celsius, we know is close to 1 gram per milliliters. Okay? But this is liter, right? So it becomes 1 times 10 to the power of 3 gram per liter. So you go okay? You okay? If yes, I would like to move on, okay? Okay, so this is the summaries. Okay, this is a summaries. So this is mass over volume. So this is good for the liquid sample. This is good for liquid sample. And this is good for the solid sample. This is good for solid sample. Okay? And so milligram per liters, or milligram, as I showed you here, milligram per kilograms. So this equals ppm. Okay? Microgram, the micro here, this equals 10 to the power minus 6. Okay? So micrograms equals ppb. So this is microgram per kilogram. Okay, and we're gonna learn one more thing. The T. The T here stands for trillion. So it's 10 to the power minus 9. Okay, so it's 10 to the power minus 9. Okay, so this is nanogram per kilogram. We know nano stand for 10 to minus 9. Pico stand for 10 to minus 12. so three important things you need to memorize is this one, is ppm, ppb, and ppt. So these are small, three important things that you need to memorize. Okay. And environmental engineering 2 will focus on the mass units. Okay, this is for environmental engineering 2. Because in this course we are dealing with the solid waste. Okay. Environmental engineering 1 is dealing with the water, the liquid sample. So they are going to use mass volume units. All right? Okay, next, I would like to explain this. The total solid. Okay, the total solid. The total solid stands for the total amount of solid materials. So this is the total solid. Actually, is total amount of solids in sample. Understand? But we simply call it total solid and abbreviate as TS. TS. Okay? So the total solid, for example, like some minerals, 矿物质, some minerals, some organic matters. Some organic matters, or even some suspended particles. Even some suspended particles, they will be included in this so-called total solid. Okay, so at this you might understand the total solid actually is total amount of solid in samples. Okay, so the total solid equals total dissolved solid plus total dissolved solid plus total suspended solid. So the total dissolved solid stands for TDS. And total suspended solid stands for TSS. Okay, and think about this. For example, like this one. I believe there are some dissolved solid in this water, right? For dissolved solid, okay, let me answer questions. For dissolved solid, for TDS, can we use filter, lids, to filter it? No, right? Because it's dissolved, right? So we cannot use filter to filter dissolved solid. However, we can use filter paper. We can use filter papers to find out how much amount of total suspended solid. Because those suspended solid cannot pass through the filter paper, right? Understand? Guys, do you understand what I'm talking about here? The suspended 悬浮的没办法通过滤 The suspended solid cannot pass through the filters. So this is the remains. Okay, so this is the remains of TSS. So TSS remains on the filter paper, right? So TSS remains on the filter paper. And which one pass through? TDS. So this is TDS. Okay. In this PowerPoint slide, you mentioned 2 microns, but this is just an example. Okay, it depends on the pore size. Okay, this depends on the pore size. Of filter, the pore sizes of filter papers. Okay? So the filter paper I use here will be smaller than 2 micron. The micron means micrometer. Okay, the micron means micrometer. So the size larger than 2 micron will remain on the filter papers. Okay. Okay, so this is the full summaries. So this is the full summaries of the solid analysis. Okay, so start with the total solid TS. Then we can do filtration, right? And the filtrates will be TDS. Okay, the filtrate means the solutions, the liquid, the solution or the liquid pass through the filter paper. And the retained matter will be TSS. Okay, and also the TSS can be divided into two kinds. One is called volatile SS, so VSS. So everyone knows volatile means, right? Volatile means it will be easily to be vaporized, right? So normally the VSS are organic matters, organic portions of TSS. Okay, doing ignitions. Okay, so you burn, ignition means burning. So you burn your TSS, the one becomes vapor. We call it VSS. We call it VSS. Okay, the one are not easily to be vaporized. We call that fixed FSS. And normally, the fixed SS are in organic matters. In organic solid. Okay? So after you get your TSS, you burn it. Okay, you burn it. Everyone, is that okay? Can you see? After you get your TSS, you burn it. You burn it. The one easily to be evaporized, 很容易就挥发的. Okay, normally they are organic matters. We call it VSS. And the remain solid, not easily to be evaporated. We call it fixed. Okay, fixed FSS. And normally they are in organic solids. Normally they are in organic solids. Everyone okay? Not very difficult to understand, right? Okay. So we spend some time to introduce those terminology because the significance for those terms, TDS is used as measures of inorganic salt contents in drinking waters and natural waters. And TSS can be used to assess. Assess means evaluate. The clarifiers. I will mention clarifier later. The clarifier performance. And VSS can be used to estimate bacterials populations in wastewater treatment system. So, name one? Okay. So let's do one example here. Okay, let's do one example here. Okay, so this is gonna be very similar to the question that I will ask in the exam. Okay, so consider a solutions of ammonium sulfide. Okay, so ammonium sulfides. So ammonium is NH4 plus, right? And sulfide is SO4 2 minus. So ammonium sulfide is NH4 2 SO4. Okay, prepared by dissolving 66 grams of anhydrous. Anhydrous means no water. An here means without. Okay, the hydrous means water. So anhydrous means no water. Okay, from 66 grams no water compound, and put that in the water. Diluting to 1 liters. So what is the concentrations of this solution in those things? Okay, in those things. Okay, so now it is, I give you 2 minutes. Okay, now it's 1:58. I give you 2 minutes to do these questions. After that, I will tell you how to do it. So let me give you atomic mass here. The N is 14. H is 1, right? S is 32. O is 16. Okay. I think everyone might know about this. Okay, time's up. Okay, first of all, we need to find out the molecular weights of ammonium sulfides. Okay, so ammonium sulfide will be 132 grams per mole. Okay, let's find out this first. So For question A, it's super easy. Okay, question A is super easy. Just 66 grain over. So the answer is 66 grain over liter. So question B is we need to convert the grain into mole, right? So for moralities, okay? So just use 66 over what we find out, 132 here. So over 132, we got 0.5 mole per liters, which means 0.5 capital M. Okay, not small letter m. The capital M and small letter m, they are different, right? Okay, next, the normal T's. Okay, normal T. Let me give you the formula. Okay, the normal T's equals the moralities times Z times Z. Okay, Z is so-called the equivalent factor, which means the products of the oxidation state times the number of group, okay, times Z. Okay, in this case, the Z is 2. The Z is 2. Okay, so it's 0.5 times 2. So we got 1 equivalent over liters, or the so-called 1.0 N. Okay? The reason we have 2 is we know that ammonia is positive 1, right? So positive 1. Okay. Times sulfates minus 2, right? So 1 times 2. The 2 here is 1 times 2. The 1 comes from the charge of ammonia group. The 2 come from the charge. Okay, but you can ignore the negative signs. The charge of sulfate. Okay, so 1 times 2, 2. As I just told you, the product here, product means 沉积. Okay, the product here is not the reactant product. The product here means times. The product of oxidation state times. Okay. So here mention more about the normative. Okay. So the normative equals the mass over liters. Okay. The mass over liters over GW. Okay. And the Z is the integers related to the number of exchangeable hydrogen ions or electrons in chemicals. Okay, and okay, the GW here, GW stands for, we write this one down. The GW stands for grain equivalent weights. Oh. Okay, the GW stands for grain equivalent weights. the GFW, the F here stands for formula. Okay, the problem probability is Z, right? So let me give you some example here. So for example, like, if I have a chemical reactions and Z. For example, like if I have a sulfuric acid. For sulfuric acid, 2 photons will be released, right? So the Z will be 2. For sodium hydroxide, 1 hydroxy group, right, will be released. So the Z will be 1. And for sulfate ions, sulfate group alone, the charge, we gotta take a look at charge. The charge equals 2, right? So the charge equals Z. So in this case, the GEW of sulfuric acid equals 98. 98 is the molecular weight of the sulfuric acid divided by 2. So equal 49. So if I ask a question, what is the GW of sulfuric acid? Okay. So the GW of sulfuric acid is 98 over 2. Equal 49. So we go okay? So 98 is the GFW. The formula weights, the grain formula weights. Okay, so let's continue these questions. Okay, so let's continue this question. Actually, I already finished. The GFW, okay, this is a short break. Okay.